was a great session. We now have a 15-minute commercial break sponsored by Boston Engineering. So Jose Vasquez, Director of Defense and Security at Boston Engineering, will provide an overview of some of their relevant capabilities. Now, Jose's done a lot, for the Navy. I remember in his Navy's Office of Naval Research, he established a number of their international offices around the world, right? So he's been tied into this industry for a long time. So get ready, have your questions ready for Jose. Use the chat function for them to be. And Jose, if you're ready, the floor is yours.
Okay, thank you very much. I am ready and going to go ahead and do that.
I'm going to stop sharing.
Okay, can you see my presentation?
It's up.
Super. Okay, so I'm Jose Vasquez. I'm the Director for Defense and Security at Boston Engineering. We're a small engineering firm here in Massachusetts, about 80 employees, about $17 million last year. So table of contents for what I'm going to do today, give you just a little bit of background on the company, and then I'm going to go head right into the talk, which is I'm going to talk about some wind profile generators and ways to test UASs in controlled environments. So with that said, the mission of our company is to improve the way that people work and live through innovative product design and novel engineering. And if you see the diagram there, it's ideate, engineer, and advance. And we do things all the way from innovation through concept and commercialization. So we help people from, in the defense world, from TRL level 2 to about TRL level 9. We certainly do not do that discovery phase ourselves, but we work with a lot of universities and other folks that do that discovery of basic novel ideas. Breadth and depth of our capabilities. We have some really great partnerships. We're exclusive partners with Analog Devices for some test sets that we make for them. And we've been doing a lot of condition-based monitoring technologies with them. We have a budding relationship and partnership with ANSYS, and going to be getting into their high-frequency simulation more as we go along. And we've had a long-standing relationship with Parametric Technologies Corporation with their softwares that they do for CAD, IoT, and also for management of equipment and material. We are ITAR certified, one of the 50 largest companies in the Boston area in the robotics. A lot of folks know us for our robotic fish that we have, which is a unmanned underwater vehicle, both a defense version and a version for security. So one swims like a fish, another one has a propulsor that articulates, and basically they can do a lot of really neat things underwater and are very highly maneuverable. We are ISO 9001 certified, also ISO 13485 for the medical side of the house. And we do FDA work for folks. And we did receive an award a couple of years ago from one of the Fortune 500 companies for taking a product all the way from idea to making 10,000 of that per month in a 9-month period of time. So we are used to working fast with folks. I listed the defense clients, some of the defense clients that we have. We have medical clients and we have commercial clients also, but just wanted to highlight some of the government work that we do. Relevant examples of things that we've been doing in the UAS space. We've done some market research for the Department of Defense on small UAVs. They were interested in analyzing airframes under 500 grams, and it was really amazing to find out how many UASs there are under 500 grams and their capabilities, and actually delving into some of them. So part of that is tracking new and emerging technologies, avoiding technology surprise. Have done some work for triggering UAVs once they're deployed, wanted to be able to upload a mission remotely and have it start and have it go on its way. We've been doing a lot of other work for the Department of Defense, a lot of buoys. We have a family of buoys that are low price and are sent off from aircraft. That work started off with NOAA and has now continued into Navy work and is expanded into a whole line of buoys that we're working on. So background for the wind profile generator and what we were looking to do for the Army. Currently, there is no standardized way to test UASs, their ability to handle under varying wind conditions. You have to wait for the winds to be appropriate, and it makes it hard to repeat tests to see if the results are consistent or not. The Army was looking to do that, 1 to 30 knots of winds. They wanted it to be portable, that 2 people could lift it, and so that's where the 130-pound limit came from. And they wanted it to be toolless. Out on the field, people lose screwdrivers and wrenches, and so they wanted the person to be able to put this assembly together and disassemble it, and they wanted to be able to assemble it in a period of an hour. And they wanted to be able to test UAS capabilities, GPS capabilities, and so they wanted us to maintain the ability to do that. So it had to be clear so that it could get the communications in, so it couldn't be an all-metal structure. In the product innovation process, we started looking at fans. We found out that in order to get 30 knots, you needed to have 4 very capable fans. We tried to do it with 1, couldn't. And in order to get the symmetry, we ended up with a 4-fan assembly. The fan that you see there in the middle picture is the fan that we selected, and it weighed under the 130-pound limit. To the right of that, you see some modeling and simulation work that we did, some CFDs to figure out if we could get the laminar flow. The blue that you're seeing there is the velocity, and it shows that we're having laminar flow inside of the test section for that assembly. Verification of the design was we eventually built one for the Army. You see in the pictures there, that was doing some testing outside of our facility. And it did meet the requirements, but one of the problems that they found was that testing devices inside of that 4-foot by 4-foot by 8-foot section, it was hard for some of the airframes to be able to maintain the to stay within the bounds that needed it to stay. So here you see some more pictures of the assembly. In the fans needed to be controlled simultaneously in order to achieve that. So we ended up having to do a variable fan, a VFD, and a controller. And you see the controller there for that. And as you can see on the bottom right-hand side, that's a Black Hornet that was tested inside of one of these devices. I'm going to show a little bit of a video. Talking about the design simulate model. This is some of the CFD analysis that was done. This is testing the prototype and refining it. This is doing inside testing. So one of the things is you don't have to be outside, but you could do your testing inside of a hangar or a facility if need be. But as I said, that small area there, 4 by 4 by 8, was a little constricted. We did some AR work in order to help people be able to put this together and doing the training for that. So this is part of the work that we did there, showing an operator what he or she would need to do, and then it had some more instructions. But that's just some of the visuals for that. This work was done for the U.S. Army Combat Capabilities Development Command, the Soldier Center. And then for the second prototype that we did for them, it was a wind profile generator version 2. One of the things that they needed was more room. They still wanted to have laminar flow. They wanted to be able to fly UASs in and out of that laminar flow to see how they performed as they came in and out. And they wanted to be able to have a system that could be reconfigured and could be scaled upward. So you could add several of these things together to test larger airframes. Again, they wanted to be able to test the GPS systems and pseudo GPS and other things. So the prototype needed not to interfere with that. This is the device that we built. It's inside a standard Connex box. It's got a large fan. Here you see the simulation of what the CFD showing the laminar box, the laminar flow area. And you see that there is a large section in there that's like 5 feet by 5 feet. Actually, it's a round 5-foot diameter circle that's got laminar flow. And we also then developed a system around it in order to be able to capture data. This is the front of the device. And this is our motion capture that we did. As you can see there on one of the arrows, it shows the UAS inside of the test area. You're able to get your XYZ position for that and be able to collect that data and then analyze it afterwards, or based on what you see, you could run it again if you wanted to do that. We're continuing to advance those capabilities. I was really hoping to show you some of the actual flight data simulation. This is currently over at KRI. However, because of some COVID delays, we have been unable to actually do the testing and verification. We did on-site testing at the facility where it was built, but we're looking forward to testing out the motion capture with it and some of the other systems and capabilities at KRI. If you are interested in using this device, please let us know. We can work with the Army and KRI to make this available. And we're also looking to further develop this through a phase 2 SBIR award. And I think I just finished on the nick of time there. So if there's any questions, I'll be happy to answer them. My information is here, and would love to answer any questions you have about this device or the other work that we're doing.
Thank you, Jose.